Modernage MCQs Physics First Year Unit 9 Physical Optics Part 5. Light of wavelength 5 into 10 power minus 7 nanometer is used to have first maximum by a grating of grating element 1 micrometer. The sine theta in the grating formula d sine theta is equal to m lambda will be option A 1.5, option B 0.5, option C 0.25, option D 0.15. The key is 0.5. Therefore, the correct option is B. Reason: from equation d sine theta is equal to m lambda, we have sine theta is equal to m lambda divided by d, or sine theta is equal to 1 into 5 into 10 power minus 7 divided by 1 into 10 power minus 6. Simplification gives sine theta is equal to 0.5. Hence, the sine theta is 0.5. The interfere fringes are produced on a screen placed at a distance L from two slits of separation D. The separation of fringes is Y. Both L and D is doubled. What will be the fringe separation? Option A, Y, option B, 2Y, option C, 3Y, option D, 4Y. The key is Y. Therefore, the correct option is A. Reason: the separation of fringes is y is equal to L lambda divided by D. Therefore, y prime is equal to L prime lambda divided by D prime, or y prime is equal to 2L lambda divided by 2D. 2 is cancelled with 2, which is equal to L lambda divided by D, which is equal to y. Hence, the fringe separation does not change. It remains y. Brake's equation for diffraction of axis is option A d sine theta m lambda, option B sine theta is equal to m lambda divided by 2, option C 2d sine theta is equal to m lambda, option D 2n minus 1 into d is equal to m lambda. The key is 2d sine theta is equal to m lambda. Therefore, the correct option is C. Reason: Bragg derived a formula for diffraction of axis falling on first and second layers of atoms of crystal separated by D at glancing angle theta. Therefore, Bragg's equation, which is known as Bragg's law, is 2d sine theta is equal to m lambda. Hence, the Bragg's equation for diffraction of axis is 2d sine theta is equal to m lambda. In mechanical waves, the particles of the medium vibrate as wave propagates. What vibrates as light wave from sun reaches the earth through vacuum? Option A, gravitational field, option B, electric field, option C, magnetic field, option D, B, and C. The key is B and C. Therefore, option D is correct. Reason: the light waves are electromagnetic waves. In electromagnetic waves, electric and magnetic fields vibrate perpendicular to each other as well as perpendicular to the direction of propagation. Hence, the electric and magnetic fields vibrate as light passes through vacuum. The ratio of the wet, bright and dark fringes in interference is option A 2 to 1, option B 1 to 2, option C 1 to 1, option D 2 to 3. The key is 1 to 1. Therefore, the correct option is C. Reason: the width of bright or dark fringe is called the fringe spacing, which is L lambda divided by D. It is same for bright as well as for dark fringe. Therefore, the ratio of the width of bright and dark fringes in interference is equal to L lambda divided by D divided by L lambda divided by D, which is equal to 1. Hence, the ratio of the width of bright fringe to dark fringe is 1 to 1. The path difference between two rays at the edge of a wedge-shaped thin film is option A 0 meter, option B lambda meter, option C 2 lambda meter, option D 3 lambda meters. The key is 0 meter. Therefore, the correct option is A. Reason: the power difference between two rays depends on the thickness of the film. The thickness at the edge is zero. Therefore, the power difference between two rays is zero. The edge of such film looks dark because of phase reversal, 0 degree to 180 degree of one of the wave reflected from denser surface. The thickness of edge of a wedge-shaped thin film is zero. Therefore, the power difference between two rays is zero. Hence, the power difference between two rays is 0 meter. Axis of wavelength 3.0 nanometer or incident on a crystal of radius spacing 5.0 nanometer. What is sine theta for the first break diffraction? Option A 3.0, option B 0.3, option C 5.0, option D 0.5. The key is 0.3. Therefore, the correct option is B. Reason: from Brake's equation, 2d sine theta is equal to m lambda. We have sine theta is equal to m lambda divided by 2d, or sine theta is equal to 1 into 3.0 nanometer divided by 2 into 5.0 nanometer is equal to 3.0 divided by 10, which is equal to 0.3. Hence, the sine theta for the first break diffraction is 0.3. A point source of light generates option A plane wavefront, option B cylindrical wavefront, option C spherical wavefront, option D elliptical wavefront. The key is spherical wavefront. Therefore, the correct option is C. Reason: a point source in space propagates light in all directions. According to Huygens principle, a wave propagates in the form of spherical wave fronts. Hence, a point source of light generates spherical wave fronts. In the case of two waves of same amplitude, if crest of one falls on the trough of the other, then the amplitude of the resultant wave will be option A 0 millimeter, option B 1 millimeter, option C 2 millimeter, option D 3 millimeter. The key is 0 millimeter. Therefore, the correct option is A. Reason: the amplitude of crest is plus A and amplitude of trough is minus A. Therefore, the amplitude of the resultant wave is plus A plus minus A is equal to 0. If amplitude A is in millimeter, then the amplitude of the resultant wave is 0 millimeter. It is the condition for destructive interference. Hence, the amplitude of the resultant wave will be 0 millimeter. In the case of two waves of same amplitude of 1 millimeter, if crest of one falls on the crest of other, then the amplitude of the resultant wave will be option A 0 millimeter, option B 1 millimeter, option C 2 millimeter, option D 3 millimeter. The key is 2 millimeter. Therefore, the correct option is C. Reason: the amplitude of a crest is A is equal to 1 millimeter. Therefore, the amplitude of resultant wave is A plus A is equal to 1 plus 1 is equal to 2 millimeter. It is the condition for constructive interference. Hence, the amplitude of the resultant wave will be 2 millimeter.